Everyone. Today's topic is general use of standardization. Okay, standardization is not only for normal distribution. Generally, we can standardize data. Okay, so I'm going to explain how to do it, and I will take example. Okay, before going to general use of standardization, I'd like to take one example of normal distribution. Application of normal distribution. Lifetime, say random variable x, a certain product follows a normal distribution when with the mean 1,000 hours and the standard deviation 100 hours. The company's marketing team is considering a warranty. Warranty offers 100% refund if the product usage time is less than 750 hours, okay, for promotional purposes. Naturally, it is necessary to consider the compensation amount, right? Compensation amount depends upon the probability of this 700x less than 700. Okay, calculate the compensation amount. They need to determine the probability that lifetime is less than 750 hours. That is probability x less than 750. We have to find out this probability. So how standardize x like this, x minus its mean 1,000 divided by its standard deviation 100. Then to the right hand side, you have to do it same way, 700 minus 1,000 divided by 100. That is, this one is going to be g, right? And this value is minus 2.5. So probability g less than 2. Minus 2.5 is equal to g greater than 2.5 because normal distribution is symmetric. Then what is it? 2.5 here. Here, 2.5. This probability we want. Then half of a normal distribution, 0.5 minus 0 to 2.5. That is 0.4938. So 0.0062. In other words, if 10,000 units are sold, then compensation will be provided for 62 of them. The marketing team can then determine whether the appropriate warranty period is 750. Okay, 700 is too high, then take it lower, or it is too small, then for example, 800, something like that, hours. By considering the expected compensation amount, okay, and the increase in sales resulting from this warranty. So, in other words, you may simulate several conditions input, okay, and you may compare the result of simulations. Of course, they can also consider setting the compensation amount at a certain percentage of product price instead of a whole 100%, okay, fully 100% refund, or something like 80% refund or 50% refund, something like that. So amount of a proportion, okay, the guaranteed lifetime hours, and how much compensate when it the lifetime is shortage, okay, or others. So this is a typical normal distribution application, I think. Okay, let's go. General usage of standardization. Standardization is not only limited to normal distribution, can be applied to any data, any distribution. Standardization often plays a significant role in data analysis. While it is introduced for purpose of calculating the probability of a normal distributed random variable, so you see standardization first in statistics, okay, for normal distribution. I said standardization is commonly used in general to what? Eliminate the unit of measurement from data. Eliminate the unit. Standardization of a random some variables, okay, involves subtracting the mean of that variable, sorry, and then dividing by its standard deviation. The resulting is generally denoted by z. You see x minus its mean and standard deviation. So you may eliminate the unit. Say upper side dollar has dollar unit, the down side bottom also standard deviation has the same unit of measurement. So dollar cancel out. So unitless. When you standardize a value or variable, the result becomes unitless. It is important to note that not all standardized variables follow normal distribution. Each standardized variable follows the same distribution of x. X has some distribution, then G follow, okay, that distribution, X's distribution. When a variable is standardized, the standardized variable maintains the same distribution as the original variable. For example, if a random variable x follows a Bernoulli distribution, the resulting g after standardization will also follow Bernoulli distribution. In other words, something like this. Okay? X is Bernoulli, then g standardized variable is x minus its mean p divided by square root p times 1 minus p. That is what? Standard deviation of x. In other words, it is that standardized one also follow Bernoulli distribution. In other words, it is crucial to remember that. I emphasize it one more time that only the mean and the variance change to 0 and 1. Okay, mean will be 0, variance will be 1. So standard deviation also takes 1. All right, let's see example. This is a company's evaluation. So Department A and Department B, they are captains, head. Department heads A and B are based on they score their men based on scale of 100 points. Okay, so head A gave score 55 out of 100 to Kim. A scores 50 for Lee. A gives 60 to Park. A gives 55 to Moon. B, department head B, scores 70 to Choi, 80 to Jung, 90 to Liu. Okay, so two different department heads A and B scores their own scale. So average and the standard deviation of evaluation scores given by A and B have different values. Of course, different values because those two person A and B have different scales for scoring. In other words, evaluation scales used by two A and B are different. Therefore, human resource department, HR department, most standardized the evaluation scores given by A and B. In other words, they needed to eliminate the unit of two evaluation scales. They eliminate the unit of A and B. So A's mean is 55, standard deviation 3.54. B's mean is 80, the mean of this 80, and the standard deviation is 8.16. Okay, so how to standardize it? For Kim here, 55 minus 55 divided by its standard deviation 3.54. To Moon here, oh, same value. What is this? I'm sorry, this is error 60. Okay, 60 minus 55 divided by 3.54 is 1.41. Okay, 1.41. For B, same thing. 70 for Choi, 70 minus its mean 80 divided by 8.16. It's minus 1.23, something like that. Then these scores, standardized scores, have no unit. So now HR department compare this persons, these people. By standardizing the scores, we can determine that the overall ranking of 7 evaluation scores. So Park, what, this one is biggest, 1.41, and next Liu, this one, this person, 1.23, it is the second, and so on. Okay, last one is Li, minus 1.41, like this. Now, nobody understand that kind of a standardized value. So additionally, the standardized scores of 7 individuals can be converted back to a score with a mean 70 and standard deviation 5. Okay, so minus 1.23 gonna be, say, what? X minus mean 70 and standard deviation 5. Then what is this guy's choice, final score? X gonna be 70 plus minus 5 times 1.23. Okay, so the HR department announced this score. Isn't it interesting? Okay, thank you. Bye.